We're going to talk about the Euclidean algorithm. It's an algorithm used to find the greatest common divisor of two numbers. So if we have easy numbers like, let's say we're trying to find the greatest common divisor of 4 and 6, we know it's 2. Let's say we're trying to find GCD of even bigger numbers, let's say 24 and 36. Just using inspection, using some logic, we can tell it's 12. But what if we have difficult numbers, like we're trying to find the greatest common divisor of 952 and let's say 493. There's no easy way to tell, especially because this is odd, this is even, so there's no factor of 2. So this is where the Euclidean algorithm comes in. And this is what calculators will use to find it if you have some calculator program. So we're going to, below this line, we're going to start it. And how you set it up is you write the bigger number first, 952, equals 493, that's the other number, times something plus a remainder. So what is that something? So we're going to make a little math box up here so we can work out some calculations if we don't have a calculator handy. If you do have a calculator handy, that'll be good. So let's just subtract 952 minus 493. So 419, 9815, 459. So we get 459, which means that this is 1 and this is 459. So this 493 times 1 plus a remainder of 459 will give us 952. And notice, as long as we have a remainder, we're going to keep doing this process. So we have a remainder here, so this process is going to keep going. And the new numbers we're going to use are these. So now we use 493 equals 459 times what? Plus a remainder. This is easy to see, this is 1, and this will be 34 as a remainder. Notice we still have a remainder, we have to keep going. Carry all these down. 459 equals 34 times what? Plus a remainder. Let's just come up here and divide 34 into 459. This is 134, 1, 9. Let's see what 34 times 3 gives us. 12, 102, 102, 17, 13. So this is going to be 13 and 17. And notice that took very little time, even using long division process over here. So notice we still have a remainder, and we're going to have to do this one more time. So notice the number in the parentheses doesn't matter. We're just going to carry over the front number, which is the remainder from the previous problem. So this is 34 equals 17 times what? Plus a remainder. So this is going to be 2, and notice the remainder is now 0. And the remainder is now 0, which is our cue that we have found the greatest common divisor, and it is 17. And that's how you do the Euclidean algorithm to find the greatest common divisor. We could have done it on the easier examples too, but we didn't really need to.